Okay, real quick, before I got over to the lab, back where the plasma spark is, I got the fuel cell set up, the electrolytes in there, and running off of a 12-volt battery. Okay, one of the questions early on that a lot of people were asking me was, how much liters per minute were you producing in hydrogen gas? And one of the ways I was measuring here at the house was I took a tube out of the fuel cell and I ran it into basically a pitcher of water, okay, and in that water I had a bottle of water, and that's got water in it, and I'd bubble that up, and when the water was pushed out of the bubble, when this water line was pushed out of the bubble from the rising bubbles that came up, I would time that and see how long it would take to fill that bottle, that 1 liter bottle, okay, of with hydrogen gas. But other videos have shown a different apparatus similar to this one, which I'll bring into the picture now, okay, where that same bottle rides up and down that inner tube. Which brings to question, who's right? What is the correct way and standard method of measuring the liters per minute? Is it the displacement of water out of the bottle? Because the hydrogen gas I'm producing will have to go up, fill the bottle, and push the water out, raising the total water level of the pitcher itself. Or is the correct method of measuring riding up and down the stick until the bottle just floats on top? On one method, I'm lifting the weight of the water here, the way I was doing it, and the other method, as I see on the YouTube videos, they're lifting the weight of the bottle. Obviously, 1 liter of water weighs a lot more than one empty plastic bottle. So I'm not saying one person's right or one person's wrong. I'm just asking, what is the standardized method of measuring this? Clearly you can get 1 liter in both bottles, obviously, but gas can be compressed. So the way I'm doing it is a much higher concentration of gas than the other way. But which is correct? Because I cannot get 1 liter in 17 seconds. Okay? I mean, I am hauling butt here with hydrogen, and you'll see. And I just now turned it on. Okay? Hydrogen production in the fuel cell. I don't know if you can see that, but it's going pretty good. And now the bubbles are coming in. That's not going to displace that water in 17 seconds. It just isn't. But it might well raise that bottle in 17 seconds. I don't know. So I'm going to try it on the other way and see what we get. And that's all I have for this recording. I'll try to record the other way.